Today we will be discussing the next colligative property, that is elevation in boiling point. So the word elevation means increase. So first we'll see what is boiling point. Boiling point of any liquid is the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure. So I'll just write it here. It is the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure. So the temperature at which the vapor pressure of a liquid becomes equal to atmospheric pressure is known as boiling point. So just do a simple experiment and so that it will become clear to you. Just we'll do a simple experiment which will make it more clear. See, just taking a beaker. In that I am taking water in which a thermometer is placed. Okay. The room temperature of the thermometer is how much? 25 degrees C. And just let us plot a graph also here. On the x-axis will take temperature and on the y-axis will take vapor pressure. Now when the temperature is 25 degrees C in the thermometer, that is at room temperature, the vapor pressure of water will be very less. Suppose this is 25 degrees C. So we'll just imagine the vapor pressure is somewhat here. It's less. Okay. So I'm just plotting it like this. Then we are supplying heat. So the water starts getting heated. So what will happen to the temperature in the thermometer? It slowly rises. So when the temperature rises, what happens to the vapor pressure also? It will increase. As the temperature rises, the vapor pressure of water will also increase. It goes like this, it will go on increasing. Now, the temperature in the thermometer is reaching 100 degrees C. And you see the water is boiling. So the temperature has reached 100 degrees C. Suppose it's this much is 100 degrees C. Okay. Again you are supplying heat, but what do you observe? The temperature in the thermometer is not increasing. You are supplying heat, the water is getting heated, but the temperature in the thermometer remains constant. Why the temperature in the thermometer is remaining constant? Why? Because the vapor pressure of water has become equal to what? Atmospheric pressure. Once the pressure becomes equal, even then you go on supplying heat, the water will not further boil. So that's the reason why we say the boiling point of water is 100 degrees C. Why? At 100 degrees C, the vapor pressure of water is equal to what? Atmospheric pressure. So this is 100 degrees C. So this is atmospheric pressure. This dotted line represents atmospheric pressure. So is it clear? You are taking water in a beaker. In that you are placing a thermometer. The room temperature is 25 degrees C. At 25 degrees C, we just imagine this is the vapor pressure. Then we are supplying what? Heat. When we supply heat, the water starts getting heated. So slowly the temperature in the thermometer is increasing. So here also what is happening? As the temperature is increasing, the vapor pressure of water is increasing. It reaches a maximum value, say 100 degrees C. Then when it reaches 100 degrees C also, you are going on supplying heat and you feel what? The water is getting heated. But the temperature in the thermometer is not increasing. Why it's not increasing? Because the vapor pressure of water has become equal to what? Atmospheric pressure. After that, once the vapor pressure of the liquid becomes equal to atmospheric pressure, after that if we supply heat also, the temperature is not going to increase. So it's just waste of what? Energy. So once the pressure of a liquid becomes equal to atmospheric pressure means it has reached the boiling point. So is it clear? Boiling point is the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure. So this curve is what? The vapor pressure curve for solvent. And this temperature at which the vapor pressure of the solvent becomes equal to atmospheric pressure is known as the boiling point of the solvent. So I am just going to write here T solvent. Now what I am going to do is, we will just cool this, and to this we will add little amount of non-volatile solute. Okay, we are adding a little amount of non-volatile solute. Now this becomes a solution. Now we are doing the same experiment. Initial vapor pressure we are noting when it is at 25 degrees C, and what you observe is it's slightly less than that of pure solvent. That is, when you are adding non-volatile solute to the solvent, what you observe at 25 degrees C, the vapor pressure of the solution is slightly less than solvent. Then again you are supplying heat. So what happens? The solution starts getting heated. So what happens to the temperature in the thermometer? It will also start increasing. So you see here, slowly the temperature is increasing and the vapor pressure is also increasing. Suppose the non-volatile solute you added is glucose, okay. Now you see, when it reaches 105 degrees C, the process of boiling has stopped. That is, you are supplying heat, but the temperature becomes constant. Why? Because at 105 degrees C, the vapor pressure of the solution has become equal to what? Atmospheric pressure. So this 105 degrees C represents what? The boiling point of what? Solution. Once more I'll explain. That is, you are adding a non-volatile solute to the solvent. Suppose you are adding glucose, which is a non-volatile solute. Then you are doing the same experiment. Initial vapor pressure at 25 degrees C you are noting, and what do you observe? It is found to be less than the vapor pressure of pure solvent. Then you are supplying heat. When you supply heat, the solution starts getting heated. So what is happening to the boiling point? It starts increasing and it reaches a maximum value, say 105 degrees C. At 105 degrees C, the vapor pressure of the solution becomes equal to what? Atmospheric pressure. So this represents what? The boiling point of the solution. What do you observe here? When you see both the graphs, what do you observe? The vapor pressure of the solution is less than the vapor pressure of what? Solvent. For the same temperature, you see the vapor pressure of the solution is less than the vapor pressure of the solvent. What is the reason for that? Because when you are adding a non-volatile solute, the surface is also occupied by what? Non-volatile solute. So what happens to the escaping tendency of the solvent molecules? It decreases. So what happens to the vapor pressure? It also decreases. See, when the solvent's vapor pressure has reached equal to atmospheric pressure, is the solution's vapor pressure reaching to atmospheric pressure? Where is it? It's at this point. Then again you have to supply heat. Then only its vapor pressure is becoming equal to what? Atmospheric pressure. So this represents what? The vapor pressure of the solution. So this is T solution. So what do you observe? The vapor pressure of the solution is greater than the vapor pressure of the solvent. Why is the vapor pressure of the solution greater than the solvent? When you are adding a non-volatile solute, the escaping tendency of the solvent is decreasing, due to which the vapor pressure is decreasing. Hence, we have to supply more heat so that its vapor pressure becomes equal to atmospheric pressure. So, this increase in vapor pressure is known as what? Elevation in boiling point, and it is represented as delta TB. So elevation in boiling point, it's coming. Why? Because when you are adding non-volatile solute, the vapor pressure of the solution becomes more than the vapor pressure of the solvent. Once more, I'll explain it. First, we are taking what, a pure solvent, and you are placing a thermometer in it at room temperature, that is 25 degrees C. We are noting the vapor pressure of the solvent. Here what we have taken, water, and this point represents the initial vapor pressure of the solvent. Then we are supplying heat. So slowly the vapor pressure is increasing. It reaches up to a maximum, say 100 degrees C for water. Then again you are supplying heat, but the temperature is not increasing. Why? Because water's vapor pressure has become equal to atmospheric pressure. So that represents the boiling point of the solvent. Now you are just cooling it, and then you are adding non-volatile solute, say glucose. And you are doing the same process. You are noting the vapor pressure at 25 degrees C. What do you observe? The vapor pressure of the solution at 25 degrees C is less than the vapor pressure of pure solvent at 25 degrees C. Why is it less? Because the escaping tendency of the solvent is decreasing when you are adding a non-volatile solute. Why? Because the surface is occupied by what? Non-volatile solute. So the process is repeated, and you see at all temperatures of the solvent, the vapor pressure of the solution is less. See, at this point, the vapor pressure of solution is this much, but at this point, the vapor pressure of the solvent has become equal to atmospheric pressure. So, for the solution to reach atmospheric pressure, we have to heat it for some more time. Then only the vapor pressure of the solution is becoming equal to atmospheric pressure. This is because of the presence of what? Non-volatile solute. So, the boiling point of the solution is represented as T solution. So, T solvent, this represents the boiling point of solvent, and this represents boiling point of solution. So, this difference in boiling point of solution and solvent is known as what? Elevation in boiling point. So, what can you write? Delta TB, which is elevation in boiling point, is equal to T solution minus T solvent. Here we had taken water as the solvent. Its boiling point is 100 degrees C, and we are added a non-volatile solute glucose, and there we got the boiling point as 105 degrees C. So what's the difference? 5 degrees C is the difference in boiling point, and this 5 degrees C represents what? Elevation in this 5 degrees C represents the elevation in boiling point. So why is this elevation in boiling point coming? The elevation in boiling point is coming when you are adding what? Non-volatile solute. So it depends upon what? The amount of non-volatile solute. So delta TB, that is elevation in boiling point, is directly proportional to the amount of the solute. So the amount of the solute, and representing it in terms of what? Concentration. So you know it, the square bracket represents what? Concentration of the solution. Because this elevation in boiling point is coming when you are adding what? Non-volatile solute. So it's depending upon what? The amount of non-volatile solute. So what can you say? The elevation in boiling point is directly proportional to amount of non-volatile solute, or we can say it's directly proportional to the concentration of the solution. Now, listen here. I have written here concentration of the solution. Now, which concentration term will you use? Because different concentration terms you have studied. That is, various methods for expressing the concentration of the solution. You have studied molarity, molality, mole fraction, mass percentage, volume percentage, etc. So, you just tell me here which concentration term are you going to use? Can we use molarity, or can you use molality? Both are concentration terms only. Whether you are going to use molarity or whether you are going to use molality. I am going to use here molality. Why am I using molality and not using molarity? Molarity is also a method of expressing concentration of solution. Molality is also a method for expressing concentration of solution. But I am using molality. Why? See here, molality is not depending upon what? Temperature. But molarity depends upon what? Temperature. Here what is happening? This variation is coming. Vapor pressure's variation is coming due to difference in what? Temperature only. Here there is variation in temperature. So, if you take here molarity instead of molality, so what will happen to molarity also? It will also change with respect to what? Change in temperature, because it's what? Elevation in boiling point. So, molarity also will change. But if you take molality, it will not change. Why? Molality is independent of temperature. So, that is the reason why we are taking here what? Molality instead of molarity. Because concentration of a solution can be expressed in terms of molarity, you can express it in terms of mole fraction, you can express it in terms of molality, mass percentage, volume percentage. So here we are preferring molality instead of molarity. Why? Because molality is independent of temperature, but molarity depends upon temperature. So if we use molarity, then because delta TB is what? Difference in temperature, so automatically molarity also will change. But here molality will not change with this difference in temperature. So we will be using what? Molality. So delta TB is directly proportional to molality, or you can write delta TB is equal to, in order to remove this proportionality sign, we are multiplying it by a constant Kb. So delta TB is equal to Kb into M, where delta TB is known as elevation in boiling point, then Kb is known as molar elevation boiling point constant, or just boiling point constant, or it is also known as molar ebullioscopic constant, or just you can call it as molar elevation constant also, or molar elevation constant. Then M is known as what? Molality. M is known as molality. So is it clear? So when you are adding a non-volatile solute to a solvent, the boiling point of the solution becomes higher than the boiling point of the solvent. So that difference in boiling point of solution and solvent is known as elevation in boiling point. And since this variation in boiling point is coming due to the addition of non-volatile solute, so it is depending upon the amount of solute which we are adding. So elevation in boiling point is known as a colligative property. So it's directly proportional to the concentration of the solution. And here we are taking molality instead of molarity. Why? Because molality is independent of temperature and molarity is depending upon temperature. So delta TB is variation in temperature. So when the temperature is changing, molality also will not change. So in order to remove this proportionality sign, we are multiplying it by a constant Kb, where Kb is known as molar elevation constant, or molar elevation boiling point constant, or molar ebullioscopic constant. See, delta TB is equal to Kb into M. Now, if molality is 1 molar or 1 mole per kg, then what will be delta TB equal to? Delta TB is equal to Kb. So, then how can you define delta TB? So, not delta TB, Kb. How can you define Kb? That is molar elevation constant. So, it can be defined as elevation in boiling point when the molality of the solution is 1 molal. That is, it is the elevation in boiling point when the molality of the solution is 1 molal, or it is the elevation in boiling point when 1 mole of a non-volatile solute is dissolved in 1 kg of the solvent. Both way you can define it. So, Kb is what? Elevation in boiling point when the molality of the solution is 1 molal, or it is the elevation in boiling point when 1 mole of solute, non-volatile solute is dissolved in 1 kg of the solvent. So, is it clear? It's the elevation in boiling point when the molality is 1 molal, or when 1 mole of non-volatile solute is dissolved in 1 kg of the solvent. Now, what will be the unit of Kb? Now, Kb is equal to delta Tb by m. Delta Tb can be expressed in Kelvin, Kb by mole per kg. So, what will be its unit? Kelvin, kg per mole, or Kelvin per molal. Or if it is in degree C, instead of Kelvin it can be in degree C also. Degree C mole per kg, which will be equal to degree C kg per mole, or degree C Kelvin per, degree C per molal. So, these are the units of what? Kb. So, why we are using Kelvin as well as degree C while doing numerical? I will specify it. So, is it clear? Elevation in boiling point, then molal elevation, constant. Elevation in boiling point is the difference in boiling point of solution and solvent. That is, when we add a non-volatile solute to a pure solvent, its boiling point is increasing. Why is the boiling point increasing? Because the vapor pressure is decreasing. Then Kb is elevation in boiling point when the molality of the solution is 1 molal, and its unit is Kelvin kg per mole, or Kelvin per molal, or degree C kg per mole, or degree C per molal. The next topic is how to find the molar mass of non-volatile solute using elevation in boiling point. So, determination of molar mass of non-volatile solute using elevation in boiling point. So, we are taking a known mass of non-volatile solute. Let the mass of non-volatile solute taken equal to W2 gram. It's dissolved in a known mass of solvent. So, mass of solvent to which it is added equal to W1 gram. Next, we are finding out its elevation in boiling point experimentally. Now, we know that delta Tb is equal to Kb into m. Then what is molality? It is the amount of solute dissolved in given amount of solvent, or the number of moles of solute dissolved in given amount of solvent. So, we can write it as Kb into N2 divided by W1 in which unit? Kg. What is N2? N2 is equal to W2 by M2 into W1 in kg. So, this you are getting. or what can you get? M2 is equal to Kb into W2 divided by delta Tb into W1 in kg. So using this equation, we can calculate the molar mass of non-volatile solute. So we know the mass of the solvent should be in kg. So most questions, the mass of the solvent will be given in grams. So you have to convert it into kg. So you can directly use this equation in such cases. Kb into W2 into 1000 divided by delta Tb into W1. Now if you are using this equation, the mass of the solvent will be in which unit? Grams. If you use this equation, it should be in what? Kg. So you should be very careful. If it is given in grams and if you want to use this equation, no need of converting grams into kg. Or if you want to use this equation, if the mass of the solvent is given in grams, you have to convert it into kg. So we are taking a known mass of a non-volatile solute, which is taken as W2, which is added to a solvent whose mass is known to you, that is W1 gram. Then we are experimentally determining what? Elevation in boiling point. Then we know delta Tb is equal to Kb into m. Then we know the definition for molality. It is number of moles of solute dissolved in 1 kg of the solvent. So we come to this derivation, and so using this equation we can calculate the molar mass of non-volatile solute. So we will just practice one numerical related to this. Now see this question. 0.15 gram of a substance is dissolved in 15 gram of solvent at a temperature higher by 0.216 degrees C than that of the pure solvent. What is the molar mass of the substance? Now 0.15 gram of a substance is dissolved in 15 gram of solvent. So what is the 0.15 gram? It's the solute. So you can write it as W2 is equal to 0.15 gram. And it is dissolved in what? 15 gram of solvent. So W1 is 15 gram. At a temperature higher by 0.216 degrees C. You have to read the questions very carefully. You should not get confused whether it is the boiling point of solution or it is elevation in boiling point. So what is given here? 0.15 gram of a substance is dissolved in 15 gram of solvent at a temperature higher by 0.216 degrees C. So this represents what? Elevation in boiling point. So delta Tb is equal to 0.216 degrees C. Then that of pure solvent. That is, when you are adding this non-volatile solute to the solvent, the vapor pressure is becoming higher. So this is elevation in boiling point. So they are asking you to calculate what? Molar mass of the solvent. And here Kb for the solvent is equal to 2.16 degrees C mole per degree C per molar. Okay. Now listen carefully here. Here delta Tb is in degree C. Now you have studied in chemistry that all calculations we do in what? Kelvin. But here I am not going to convert degree C into Kelvin. The reason is what you see here. I'll just show you. When we did the experiment for elevation in boiling point, the boiling point of the solution was 105 degrees C and that of the solvent was 100 degrees C. So the difference comes to be how much? 5 degrees C. Now 105 degrees C will be how much? 378 Kelvin minus 373 Kelvin. So that difference is also coming how much? 5 Kelvin. So this represents what? Difference in temperature. So 0.216 degrees C is equal to what? 0.216 Kelvin. So elevation in boiling point, if it is given in degree C or if it is given in Kelvin, it's the same. You are not going to change. You are not going to convert degree C into Kelvin. If you are going to convert this, the total thing will go wrong. So got the difference? 105 degrees C minus 100 degrees C is 5 degrees C. It's the same only. Here also you will get, because it represents what? Difference in temperature. So you have to calculate M2. Now mass of the solvent is given in which unit? Grams. So you can directly use this equation. M2 is equal to W2 into Kb into 1000 divided by delta Tb. So which will be equal to 0.15 into 2.16 into 1000 divided by 0.216. So when you calculate it, it comes to be 100 gram per mole. So this is how you have to do the numericals. The main thing you have to keep in mind is the elevation in boiling point. If it is given in degree C, you will do it in degree C. If it is given in Kelvin, you will do it in Kelvin. You are not going to convert it. If you go to convert it, the total thing will go wrong. So boiling point is the temperature at which the vapor pressure of a liquid becomes equal to atmospheric pressure. When we are adding a non-volatile solute to a pure solvent, the escaping tendency of the solvent molecule decreases because non-volatile solute occupies some of the surface area. So what happens? The vapor pressure of the solution is decreasing. So at a higher temperature only, the vapor pressure of the solution becomes equal to the vapor pressure of the atmosphere. So the boiling point of solution is greater than the boiling point of solvent. So this difference in boiling point of solution and solvent is known as what? Elevation in boiling point. And since it is coming due to the addition of this non-volatile solute, so we can say elevation in boiling point is a colligative property, and therefore here we have taken delta TB is directly proportional to molality and not molarity. Why? Because molarity depends on temperature and molality is independent of temperature, and we derive the relation delta TB is equal to Kb into m, and we defined Kb. Kb is elevation in boiling point or molar elevation constant, and it is defined as elevation in boiling point when 1 mole of non-volatile solute is dissolved in 1 kg of the solvent. Then we derive the expression for calculating the molar mass of the non-volatile solute, and that expression was M2 is equal to Kb into W2 divided by delta Tb into W1. And we just did one numerical. The remaining numericals we'll do it in the next class, and you can practice it from your textbook. So today I'm winding up here.